Yes, good. Okay, on 5.7, let me get your attention here, please. On 5.7, one of the things they talk about, now we went through how to graph linear inequality, or quadratic inequalities. Very simple. We just use inequality for that, not a big deal. But if we want to solve an equation, it's a little bit different. Okay, now how do we do this? If we want to solve the quadratic inequality, 2x squared minus 7x plus 3 is greater than or equal to 0. If you can't see this real well, just it's on that sheet I gave you. So we want to find the x values. Like always, when we're solving an inequality, we just want to find all the x values that are going to make this true. All the x values that are going to make the expression 2x squared minus 7x plus 3 greater than or equal to 0. Okay, here's the trick for doing that. The way the book goes through this, it's really confusing, and I don't think it's the best way to go about this. We can do this much easier with a sketch. If we sketch this, here's how we want to think about it. If we just sketch the parabola, so let's ignore the inequality for a second and just consider the function y equals 2x squared minus 7x plus 3. Okay, if we want to sketch a graph of that, all we want to know on the graph is where does that graph fit this, what the inequality is asking. But what is it asking? Now think about this. Solving the inequality 2x squared minus 7x plus 3 is like asking the question, when are the y values that it calculates greater than or equal to 0, right? Because if I graph this parabola, really all this stuff is doing is telling me what the y value is that goes with each of the x values that I put in, right? Does that make sense? If I, for example, if I put in x equals 1, and I evaluate this expression, it's going to spit out a number for y. I just want to know when are those y values that it's spitting out greater than or equal to 0. Okay, so if we were to sketch this parabola then, that's just like asking when y is greater than or equal to 0, what does that mean in terms of the graph? We want to find all the x values. So maybe a better way of saying this is, for what values of x is y greater than or equal to 0? What does that mean in terms of our sketch, though? That's the important thing. When y is greater than or equal to 0, where is that going to be on the parabola in the xy plane? What parts of the parabola that I sketch? I haven't even sketched it yet, but I will sketch. What parts of that parabola are we talking about? Where is that on the xy plane? In what parts of the xy plane, which goes on forever, but in what parts of the xy plane is y greater than or equal to 0? Where is y greater than 0 on the xy plane? When you're above, okay, when you're above 0, but tell me, be descriptive in terms of what the xy plane looks like. So if I have the xy plane, let's just graph that real quick. So here's the xy plane. Right, there's the y-axis, there's the x-axis. What part of the xy plane are we on when y is, say, greater than 0? Okay, it could be on the y-axis, but it could be at a point someplace. What do you think, Chance? Anything above the x-axis, right? Wouldn't you agree that like this point right here, I don't really care in this case what the x value is, but wouldn't you agree that the y value, the y coordinate is bigger than 0? And that y coordinate is bigger than 0, but that one is less than 0, right? And that one is less than 0. So if I want to know where is y greater than 0, I'm just asking where are we above the x-axis, right? What are the y values below the x-axis? Less than 0, right? So if I'm answering the question when is y less than 0, I'm looking for the parts of the sketch that are below the x-axis. Now, where is y equal to 0? On the x-axis, right? Because any point that's actually on the x-axis, like for example, this point right here, I don't know what the x-coordinate is, but the y-coordinate is exactly 0, isn't it? Right? Okay, so we can summarize that then. We know that y is greater than or equal to 0 would have to mean on or above the x-axis, because y equals 0 is on the x-axis. y is greater than 0 means above the x-axis, and y is less than 0 means below the x-axis, and this would be a combination of greater than or equal to, right? So that's like asking the question, when is our sketch on or above the x-axis? So all we have to do then is draw a rough sketch of the parabola, and that sketch is going to give us our answer, okay? If I want to sketch this parabola, there really are only two things I need in my sketch. It does not need to be accurate at all. All we have to know is, where are the x-intercepts? So where does it cross the x-axis, and does it open up or down? Doesn't that make sense? Right? That's all I really need. And so to find the x-intercepts, I'm just going to, set this thing equal to 0. My original equation, the quadratic equation, equal to 0, and solve it any way I want to. I got a bunch of methods now. This is what Chapter 5 is all about, is solving quadratic equations. If we can, we'll always just isolate x and square root both sides. That's the easiest way, definitely. If we can't, if we've got x squareds and x's in there and we can't isolate x, then we'll factor if it's easy. But if it's not real easy to factor, what are we going to do if I want to solve a quadratic equation? Like this one, for example. In this case, here's the equation I'm solving, right? I'm solving 2x squared minus 7x plus 3 equals 0. I've got a 2 in front of the x squared. I don't feel like factoring that. What do I do instead? Quadratic formula. Yeah, absolutely. I'll just plug it into the quadratic formula. And if I do that, I'm going to get the answers. Let's see. I know that a is 2, b is negative 7, c is 3. If I plug all that stuff in and just do the work, right? I just simplify this thing. It ends up boiling down to 7 plus or minus the square root of 25 over 4. Square root of 25 is just 5. So 7 plus or minus 5 over 4. Well, 7 plus 5 is 12, divided by 4 is 3, right? 7 minus 5 is 2, divided by 4 is 1/2. So my two x-intercepts are going to be x equals 3 and x equals 1/2. Does this parabola open up or down? Up. Opens up, right? Because a is positive. So then this is going to be the sketch. I don't need to know anything particular, but I just need to have a sketch of this thing. That's what my sketch looks like. All I really need to know is that it opens up, and here's the key point, that my x-intercepts are going to be at negative 1/2, sorry, positive 1/2, and positive 3, right? And it opens up. So if I want to shade the parts of that parabola, my sketch, that are on or above the x-axis, where would those be? I mean, wouldn't those be right here? I gotta scoot this thing over a little bit, maybe. Wouldn't those things be right there? Right? Does that make sense? If I take my parabola, in my original question asked, us, when is this parabola 2x squared minus 7x plus 3 greater than or equal to 0? So the part we're focusing on is, by the way, there it is. Hello, buddy. How are you? There we go. Okay, so that's the part I'm interested in. That tells me the part of the parabola that we're interested in. We want the part that's, of whatever this parabola is that we're going to sketch, we want the parts of that parabola that are on or above the x-axis, because we want when it's greater than or equal to 0, right? So going down to our sketch, oh, shoot. Jeez. All right, try this again.
Get your crap together.
I know. You think so, huh? So if we go down here, then that's the part we're looking for, right?
Can I talk to one of your students really quick?
Go ahead, real quick.
Yeah.
Take him out in the hall. Why don't you guys go out in the hall?
Okay.
Oh, never mind. You're done. Okay.
Yep.
Okay.
I got real quick.
All right. You got it. That was quick. Okay. So then this is the part we're interested in, but the question is only asking for x values, right? We wanted our sketch we're trying to find out where is the parabola, where are the y values on our sketch, on or above the x-axis. But when we say where, what we're really asking for is for what values of x, right? That's what where really means, or when, whatever you want to say. For what values of x is y greater than or equal to 0? And we're just trying to find those x values, right? We want the x values that are going to make this statement true. So looking at my sketch then, which x values are we talking about? What are the x values that go with that part, those parts of the parabola? If I were to look at any of these points on here, like if I were to look at this point right here, for example, think of its coordinates. Its coordinates are x equals 0, y equals 3, right? What about this point right down here? Well, this one looks like its coordinates are x equals 1, y equals -2. Which of those 2 points works? Which of those 2 points is giving me a y value that's greater than 0?
0.
That one is, right? So x equals 0 is a value that works, but x equals 1 is not a value that works. So if I'm just trying to find the x values that go with the shaded part, isn't it sort of like just taking the parabola and squashing it down onto the x-axis to find the x values? Right? In fact, aren't these really the x values we're interested in?
Yes.
In red? Okay. A couple ways you can think about it. I think the squashing thing works. You can squash it down. Or the other way of thinking about it is, what if I were to shine flashlights from above and below? Where would the shaded part of the parabola make a shadow? Well, if I shined it straight down in this case, wouldn't the shadow be out on the sides? Right? And so my answer, I know, in this case, if I'm just looking for those parts of those x values, I know it's going to be an or situation because I've got 2 separate intervals that are like the oars on a boat. Either x is going to be less than or equal to whatever that x-intercept ended up being, 1/2, or x is going to be greater than or equal to this x-intercept, right? See how that works? So it's real simple. All you got to do, the only math you have to do is the same math you've been doing. You got to do some algebra to find out what are the x-intercepts. But the rest of the answer is just based on this little sketch that you do. Okay? Let's look at another one. Let's just go through one together. I'll pick one out of the book. Oops. Okay, so how about
Oh, there it is.
okay, so these are the kinds solving by graphing or solving algebraically. Either one of these we're going to do the same way. How about okay, let's do that's good. We'll do this one.
I had a dream you were my pastor last night.
You did?
Yeah, it was so weird. Except for you weren't wearing anything pastory. You were wearing your freaking Buck Pride red shirt.
You know what?
And your cat. No, you were wearing jeans and your tux. It was weird. And there was nobody there. Except for like a couple families.
Okay, what about that one? Okay, if we want to solve this right now, I just want to know when is the parabola (x squared minus 2x plus 8) what? If I think about greater than or equal to 0, what does that mean in terms of my graph? What does that translate to on the xy plane? I want y values that are what? Okay, above or on, right? Because I've got equal to and greater than combined, so it's going to be on or above x-axis, right? Does this parabola open up or down?
Goes down.
Goes down. Okay, so if I sketch this thing, then here's my parabola, right? It just depends where the x-axis hits this thing, if it hits it at all. What if it doesn't even hit it? What if it doesn't hit it? What if there are no x-intercepts? Then doesn't that mean that the x-axis is up here somewhere? And then I'd get no answers, right? I'd get no solution. Does that make sense?
Yeah.
But it's not really interesting if that happens. If that happens, we know that's the answer, but probably it's going to be something like this. There's the x-axis, and it actually does intersect it someplace. So if I'm looking for the part that's on or above the x-axis, am I looking for the, which part of the parabola am I looking for? Am I looking for the tails of the parabola or the loop of the parabola? Because it's always one or the other. On or above the x-axis. So which part of this parabola is on or above the x-axis? Yeah, it's going to be the loop, isn't it? I want the part that's on the x-axis or up. So I'm looking for this part right here. Right? Do you see what I mean when I say, are we shading the tails or the loop? The tails are going to be the parts like we did last time, right? The ends, and the loop is going to be the part in between. So whereas last time our answer was an or statement, or's on a boat, this is an and statement, isn't it?
Yep.
I know that my answer is going to be, I'm going to get x is greater than or equal to whatever that number is, and x is less than or equal to whatever that number is for my answer, right? I just got to know what those numbers are. I got to know where does this downward opening parabola cross the x-axis. So to do that, I'm just going to take my original inequality and solve the equation. Negative x squared minus 2x plus 8 equals 0, right? I'm going to ask the question, in other words, when is this equal to 0? When is it on the x-axis? What are the x-intercepts? Okay, so let's do that. So now we can just kind of shift into algebra mode here and just forget about the graph for a second. Because all we're trying to do is find those x-intercepts so I can fill in the blanks. That's it. And then we're done. So how would I solve this? No.
Positive 2 plus or minus square root.
Okay, I could use the quadratic formula, but either way, if I factor or use the quadratic formula, there's one trick I threw at you here. Do I want to have a negative number in front of x squared? Good. I don't want a negative number there, so I'm going to multiply both sides by -1 and change all the signs, right, when I solve this thing. So this one's going to become positive x squared, that one's going to become positive 2x, that one's going to become minus 8. And then I could use the quadratic formula, that's fine. Does this factor? Are there two numbers that multiply to -8 and add to positive 2? Because if it does factor easily, that definitely is easier than the quadratic formula. Yeah. X plus 4 and x minus 2. And so what are my zeros then? Either x equals -4, right? Because x plus 4 is 0 when x is -4, or x equals positive 2. So those are my numbers. Now, if the numbers are x equals -4 and positive 2 on my sketch, which one goes where? What's that one got to be? It's got to be -4, because this is the x-axis, so lesser numbers go to the left, right? So this one is -4, that one's positive 2. That's my answer. That's slick. That's so slick. And it's so much easier than the alternative. Right? I kind of like that one. I'm pretty proud of that one. Okay? Now, obviously, if you have your graphing calculator, this would be a pretty easy problem, right? If you had your graphing calculator, instead of sketching it, it would actually create the graph for you, wouldn't it? But you still got to get the answer. If I were to, on my graphing calculator, if I were to graph y equals -x squared minus 2x plus 8, I would have gotten this, right? Everybody agree? I still need to know, though, that I'm looking for the parts that are on or above the x-axis. And so on my graphing calculator, I would still want to find those x values. But I'd have the advantage of being able to ask the graphing calculator, what is that x-intercept? And what is that x-intercept? And then I would just know that it's all the values in between, right? On or between. So what does that look like on my calculator? Let's just quickly see that, because there's a couple little tricks to that. So here, y equals. Okay, so if I put in -x squared minus 2x plus 8. Okay, and I'm just gonna go, I'll just go zoom 6, how about? We'll see what that looks like. So there it is, right? There's my parabola. I want the parts on or above the x-axis, so I just need to know what the intercepts are. So you know how to find intercepts on here? Second, calc, 0. Not because we don't want intersections of curves. We want the x-intercepts, which are the same thing as zeros. Because what does 0 mean here? 0 is really asking the question, where does y equal 0? So we'll choose 2. Then all we have to do is follow the instructions. If I want to find this one, I have to pick a left boundary. So I'm just going to trace over to the left a little bit until I get left of the x-intercept. So like right there would work, wouldn't it? So I'll hit enter, and it accepts that as the left boundary. It's going to look. It's only going to search between the left and right boundaries. Now it wants a right boundary, so I'll scoot up to the right of the x-intercept. So right there is fine. Hit enter. Now it's going to bracket its search, so it only looks in there. And then it wants a guess. Just any value in between will work. Got to pick a value between my left and right boundaries, and it tells me -4 is one of my answers. Well, I knew that, right? -4. And I could do the same thing for this guy. I could go back and go second, calc, 0. Do the same process, and it would tell me that the answer was 2. And so then I still have to put that into an inequality, though. Now I know that that's -4 and that's 2 based on my graph. And so my answer would be still just this. Whoops. Would just be this. Right? Yes, sir. The -4 and the 2, because I just solved to find the x-intercepts of this parabola, right? I just set it equal to 0 and solved, right? And so that was this process here. So I multiplied by -1 to get rid of that negative sign, and then I factored it. Or if I had the benefit of my graphing calculator, I just graphed y equals that, -x² minus 2x plus 8, and asked the graph, where are the x-intercepts? Okay? Make sense?
Yes.
All right. 209.
You want these back?